We present DINAR, diffusion inpainting of neural textures for one-shot human avatar. Our approach allows one to create realistic rigged full-body avatars from single RGB images. Our method uses neural textures combined with the SMPL-X body model to achieve realistic quality of avatars while keeping them easy to animate and fast to infer. Our approach achieves state-of-the-art rendering quality and good generalization to new poses and viewpoints. Our architecture starts with an RGB image and a parametric SMPL-X body model. During training, we fit SMPL-X models to the train images using an implementation of Simplify. The main part of the neural texture is then generated using the encoder-generator architecture and has 16 channels. The encoder is based on the StyleGun2 discriminator architecture. The generator has the architecture of the StyleGun2 generator and converts the vector representation into the neural texture. We also sample RGB texture using UV mapping defined for the SMPL-X model. This RGB texture allows us to explicitly save information about high-frequency details and original colors, which are hard to preserve when mapping the whole image to a vector of limited dimensionality. We concatenate neural channels with RGB channels along with the binary maps of sampled pixels. Then we rasterize the SMPL-X body mesh in a target pose with the superimposed 21 channels texture. A convolutional renderer then generates the final image with a mask. We train avatars with pixels losses, namely L2 and L-pips, and add an adversarial loss on top to make an avatar look more realistic and sharp. The networks in our pipeline are trained end-to-end using 2D images and videos. We thus do not need 3D scans or realistic 3D human models. The easiest way to obtain an avatar that can be rendered from arbitrary angles is to stitch it from several images by merging the corresponding neural textures. Towards this end, we can merge textures corresponding to different views using weight maps obtained from angles between the normals and the view directions. By merging few textures from different views, we can get rigged avatars that can be rendered from any viewpoint. However, in this work we want to solve a more ambitious task and to generate realistic rigged avatars from single images. To do that, we propose to use neural texture inpainting based on denoising diffusion. To reduce memory consumption and to improve the network convergence, we first reduce the neural texture size using VQ-GUN autoencoder analogously to the reduction of an RGB image size performed in latent diffusion. We then train diffusion model using supervised learning, where we use the incomplete textures based on single photographs as conditions for the diffusion network. Textures aggregated from multiple views serve as targets. First we downsample input and ground truth neural textures with VQ-GUN encoder. In more detail, we pass the input texture to the diffusion model along with the inpainting mask. On each training step we train the denoising network to predict noise from the noisy target image. As usual, noise magnitudes correspond to uniformly sampled denoising steps T. During inpainting, the denoising model iteratively generates inpainted texture starting from pure noise. Our diffusion-based approach demonstrates less artifacts compared to the STYLE-People approach. STYLE-People is similar to our model but performs inpainting by doing inference in the latent generative model of neural textures. Our approach doesn't suffer from color artifacts and geometry restoration errors like Arch and Arch++ approaches. Using the whole information from the given image allows us not to copy unwanted patterns from front to back. Using sampled RGB texture as an addition to the neural texture allows us to keep realistic facial details and to preserve high-frequency details in the frontal part. Realism and ease of animation open interesting and useful use cases of our approach. One of them is bringing photos to life. In these examples, we used a separate neural network to remove the person from the original image and then superimposed an animated avatar obtained with our approach on top. Thank you for watching.